Oxides of nitrogen. Nitrogen forms a number of oxides in different oxidation states. The names, formulae, preparation, and physical properties are like this. N2O, dinitrogen oxide, or nitrogen 1 oxide, oxidation state is +1, can be prepared by heating NH4NO3. It's a colorless gas and neutral in nature. Nitrogen monoxide, NO, oxidation state is +2. It can be prepared by treating NaNO2 with FeSO4 and sulfuric acid. Or you can use N2 plus O2 gives rise to 2NO at 2000 Kelvin temperature. It is a colorless gas and neutral. It is paramagnetic. N2O is diamagnetic. Dinitrogen trioxide, N2O3, oxidation state +3. It is also called sesquioxide. NO plus N2O4 at 250 Kelvin, N2O3 is prepared. It's a blue solid, acidic in nature. When it is dissolved in water, you will be getting their HNO2. Nitrogen dioxide, NO2, oxidation state is +4. It can be prepared by treating or heating lead nitrate. Lead nitrate and heating use NO2. And oxygen will also come in this reaction. Very interesting. One colored gas, one colorless gas. Oxygen colorless. NO2 is brown color gas which is acidic in nature. NO2, when you dissolve in water, it forms HNO2 and HNO3. So it is called mixed anhydride. Important line. Dinitrogen tetroxide, N2O4, oxidation state is +4. NO2 on cooling forms N2O4. N2O4 on heating forms NO2. It's a colorless solid, liquid, acidic, colorless solid or liquid, acidic in nature. And the important line is it is diamagnetic. NO2 is paramagnetic, N2O4 is diamagnetic. Dinitrogen pentoxide, N2O5, oxidation state is +5. It is prepared by dehydrating HNO3 with P4O10. It's a colorless solid, acidic in nature. Then coming to the structures of this, very interesting. N2O will be having N double bond, N double bond O, or you can say N triple bond, single bond O. The bond lengths are nitrogen length is given here is 113, nitrogen oxygen 119. No need to remember this. N double bond O for NO. Actually, there will be triple bond which is with a 3 electron bond, very special 3 electron bond, where the bond length is 115 picometers. No need to remember. N2O3, there will be N single bond. One oxygen will be having 2 oxygens, another nitrogen will be having 1 oxygen. One nitrogen with 2 oxygens, another nitrogen with 1 oxygen. NO2, it is bent in shape, angular. N2O4, 2 NO2 groups to be added. N2O5, there will be non-linkage, NON linkage will be there. No need of remembering all this data. Why does NO2 dimerize? NO2 contains odd number of valence electrons. It behaves as a typical odd molecule. On dimerization, it is converted to stable N2O4 molecule with even number of electrons. Fine. Then coming to nitric acid. Nitrogen forms oxo acids such as H2N2O2. Hyponitrous acid. It is a dibasic acid. Oxidation state of nitrogen will be +1. HNO2 +3 nitrous acid and HNO3 nitric acid +5 oxidation state. Amongst these, HNO3 is the most important. So we are going to discuss about HNO3. HNO3 preparation. In the laboratory, nitric acid is prepared by heating KNO3 or NaNO3 and concentrated H2SO4 in a glass retort. NaNO3 plus H2SO4 gives rise to NaHSO4 plus HNO3. On a large scale, it is prepared mainly by Ostwald's process. This method is based upon catalytic oxidation of ammonia by atmospheric oxygen. For ammonia, 5O2, platinum or rhodium gas at 500 Kelvin, 9 bar pressure, 4NO plus 6H2. Nitric oxide thus formed combines with oxygen giving NO2, NO plus O2, NO2. Nitrogen dioxide so formed dissolves in water to give HNO3. This is very interesting. 3NO2 plus H2O gives rise to 2 HNO3 and NO, kind of disproportionation. NO thus formed is recycled, and the aqueous HNO3 can be concentrated by distillation up to 68% by mass. Further, concentration to 98% can be achieved by dehydration with concentrated sulfuric acid. These lines can be easily converted into questions. Properties. It is a colorless liquid. Freezing point 231.4 Kelvin, boiling point is 355.6 Kelvin. No need to remember. Laboratory grade nitric acid contains 68% of the HNO3 by mass and has a specific gravity of 1.504. In the gaseous state, HNO3 exists as a planar molecule with the structure as shown. Planar molecule, we know. One nitrogen with dative bond oxygen, one nitrogen with OH, another nitrogen with double bond. Double bond. Nitrogen, double bond oxygen, dative bond oxygen, single bond OH. Sorry. Here, what given is no need of nonsense things. 130 degrees angle is given. It's okay. There is no need to remember these angles. 130 degrees angle is given between two oxygens. Nitrogen, oxygen, 121 picometers. Oxygen, hydrogen, 96 picometers. Nitrogen, oxygen, 140. No need to remember. Oxygen, hydrogen, nitrogen bond angle is given as 102 degrees. You can't remember many things. In aqueous solution, nitric acid behaves as a strong acid and giving hydronium ions and nitrate ions. Direct question, direct point. Concentrated nitric acid is a strong oxidizing agent and attacks most metals except noble metals like gold and platinum. The products of oxidation depend upon the concentration of the acid, temperature, and the nature of the material undergoing oxidation. Copper with dilute HNO3 gives copper nitrate and NO, whereas concentrated HNO3 gives copper nitrate and NO2. But zinc with dilute HNO3 gives zinc nitrate and N2O, and with concentrated HNO3 gives zinc nitrate and NO2. Okay, now there is a difference, so this can be converted into question. Copper dilute NO, zinc dilute HNO3, N2O. Some metals like chromium, aluminum do not dissolve in concentrated nitric acid because of the formation of passive film of oxide on the surface. We can say they become passive. Aluminum becomes passive when treated with concentrated HNO3. Concentrated nitric acid also oxidizes nonmetals and their compounds. Iodine is oxidized to iodic acid HiO3, carbon to carbon dioxide CO2, sulfur to H2SO4, and phosphorus to H3PO4. In all these reactions, NO2 is formed. That is most important. Brown ring test. The familiar brown ring test for nitrates depends on the ability of Fe+2 to reduce nitrates to nitric oxide, which reacts with Fe+2 to form a brown colored complex. The test is usually carried out by adding dilute ferrous sulfate solution to an aqueous solution containing nitrate ion, and then carefully adding concentrated sulfuric acid along the sides of the test tube. This you are going to do in the lab also. You are going to perform in the lab. A brown ring in the interface between the solution and sulfuric acid layers indicates the presence of nitrate ions in the solution. See, first nitrate ion is converted to NO by Fe+2. Fe+2 is oxidized to Fe+3, NO3 minus is reduced to NO. That NO will be joining with iron. Okay, now FeH2O taken 6+2 plus NO gives rise to FeH2O taken 5, NO overall +2. Here iron will be in the +1 oxidation state. NO is also in the +1 oxidation state. It is believed. Iron +1, NO +1 in the brown ring test. Most common question. Uses. The major use of nitric acid is in the manufacture of ammonium nitrate, for fertilizers and other nitrates for use in explosives and pyrotechnics. It is also used for the preparation of nitroglycerin, trinitrotoluene, and other organic nitro compounds. Other major uses are in the pickling of stainless steel, etching of metals, and as an oxidizer in rocket fuels. So, coming to phosphorus allotropic forms. We can make this lesson into 4 classes. Okay, now 4 classes very comfortably you can teach of 50 minutes duration. So this will be in your 3rd class. This must be in your 3rd class. Okay. So what I do, I am giving you the same way. So this is a teaching class for Teaching class for teachers. Fine. Phosphorus allotropic forms. Phosphorus is found in many allotropic forms, the important ones being white, red, and black. White phosphorus is a translucent white waxy solid. It is poisonous, insoluble in water but soluble in carbon disulfide, and glows in dark chemiluminescence. It dissolves in boiling NaOH solution in an inert atmosphere, giving pH 3. It's a disproportionation reaction. We know P4 plus 3 NaOH plus 3 water gives rise to pH 3 plus 3 NaH2 PO2. White phosphorus is less stable and therefore more reactive than the other solid phases under normal conditions because of angular strain in the P4 molecule, where the angles are only 60 degrees. It readily catches fire in air to give dense white fumes of P4O10. P4 plus 5O2 P4O10. It consists of discrete tetrahedral P4 molecules as shown in figure 7.2. 7.2 figure shows phosphorus atoms are at corners of the tetrahedron and 60 degrees is the angle. Okay. Red phosphorus is obtained by heating white phosphorus at 573 Kelvin in an inert atmosphere. 573 Kelvin, remember. In an inert atmosphere for several days. When red phosphorus is heated under high pressure, a series of phases of black phosphorus is formed. Red phosphorus possesses iron gray luster. It is colorless, non-poisonous, and insoluble in water as well as in carbon disulfide. Remember, here it is insoluble in water as well as in carbon disulfide. We were saying white phosphorus is insoluble in water but soluble in carbon disulfide. There is a difference, you see. Chemically, red phosphorus is much less reactive than white phosphorus. It does not glow in the dark. It is polymeric, consisting of P4 tetrahedral linked together in the manner as shown in figure 7.3. Same figure, only links are there, extra links. Black phosphorus has two forms of alpha black phosphorus and beta black phosphorus. Alpha black phosphorus is formed when red phosphorus is heated in a sealed tube at 803 Kelvin. It can be sublimed in air and has opaque, monoclinic or rhombohedral crystals. It does not oxidize in air. Beta black phosphorus is prepared by heating white phosphorus at 473 Kelvin under high pressure. It does not burn in air up to 673 Kelvin. So you do one thing. You teach to the students the oxides of nitrogen, oxyacids of nitrogen in that HNO3, then phosphorus forms in your third class. First class should be about the general properties. Second class about the, hydrides, oxides, and halides. General compounds are there, those compounds. Then you can go for nitrogen. As well as ammonia in second class. This will be in your third class. Fourth class will be about phosphine and phosphorus oxyacids. That's all. 4 classes you can very comfortably teach. So this is class 3 of group 15.